Yes, sir.
Yes, please tell me.
Sir, in the assignment you have given, sir, there the question consists of that roll number we have to display. What is that? Hello, sir.
Yes, yes, it was disconnected. Please continue.
Oh, sir, there in the question of the assignment, sir, there is that we have to mention a roll number. Sir, what is that?
Oh, when you display uh, the system call, at least you can display your roll number so that you can know that whether it is cheated or not. Since you are making a group,
Mm,
and that is the purpose. Otherwise, nothing.
Sir, and how to submit like all the
Yes,
group
sir.
members will be
One you have to submit it. One you have to submit it. If you have not done today, I'll make a group actually. Yesterday or day before yesterday, I found your groups. Somebody has sent me all the 7 groups. So
So,
accordingly,
but we have already made the group and done it almost. Just
I'm
sign
not saying whatever. I'm saying that whatever the group you have given now, that group I'll make in the middle. So
Okay,
that to show you only one link where you have to submit. Are you getting?
Sir, either of us will submit or all the group members need to submit?
Anyway, one has to be submitted.
Okay, okay.
Sir, in the format of document or like Git commits?
No, you have to submit 2 things. One is your zip file of the whole XB6 along with one PDF file where the description or wherever you have changed those things will be present.
Sir, like in the G file, means after doing all the editing, like
Yes,
that
yes,
adding
yes, yes,
cut,
yes, yes.
the complete thing, no?
That is complete. After,
Okay,
after
sir.
you are doing everything, it has to be run now. It must be run or
Mhm.
partially run something.
Yes,
Some
sir.
command must be run, some commands are not running, that's okay. But at least some commands are running and that whole zip file of the XB6 has to be submitted. Okay, so that I can run and verify.
Sir, and in the PDF, we will have that Git difference or that, like that.
No details you have to tell that in which file you have changed.
And
What
that's
kind of change? What suppose you have written 5 lines in the wait function. That 5 lines you have to write only.
Sir, and that screenshot also, that it is working or not. No?
Necessary. I'll check.
Okay.
I'll run once. Huh?
Okay, sir.
That's it. But if you add a screenshot, it's good. Looks good. But if you don't add, that is not mandatory. That you have
Sir,
to
and
add.
today is the last date, no?
Today is the last date, 15th. 15th or 14th I had given. Check. Otherwise, today I'll give. Even if it is not there, I'll give today. Huh? I'll extend.
Yes, sir.
Don't worry.
Yes, sir.
Excuse me, sir.
Yes, please, quick.
Sir, on 3rd February, you given a round-robin question to solve, including Iowa. Can you please solve that question? I mean, I'm not sure whether my answer is correct or not.
If you can send me, I'll solve and send to you. That will be good.
Okay, okay.
Or I'll do it. That will be easier.
Okay.
Why will you waste time here? That I'm saying. If you don't mind it, sir. Huh?
No
You just give me a question. Once again, I'll solve in a paper and just attach in the middle.
Okay, sir.
Okay. That's right.
So you will make the groups today and then we have to submit, like from one group, one person.
If you are not finding the group as made by 7 o'clock in the evening, then you can submit it one person from that group. Okay. I hope I'll make it by 7. Huh?
Okay.
By 7 I'm saying. Huh? After 7 you submit. Okay. Evening 7. Fine. So we'll go for this because this is important for your medicine. That's why I'm saying. And regarding few medicine questions, you can also collect short questions if you're finding, so that someday we can discuss with respect to synchronization. Many questions usually comes from synchronization. Be ready. Huh? So last class we have studied what are the different kinds of locks. So hardware lock we are finding, software locks we are finding, and then after we look into that where the lock may not work. So one scenario we are looking here, if there is a common shareable file that is f1.txt, if I want to read and write into this file, I have to make a lock usually. So if one process is going to read that file and another process is going to write that file, so obviously I'll apply a lock here so that only one person will be allowed, either P1 or P2. If P2 has entered into write into this critical section area, P1 cannot enter because he has already put the lock. Once this person will be come out, then another person can enter into this. So in this way, we somehow achieve it. But one scenario comes where this cannot be a actual work. When more than one person wants to go for reading, if more than one person is going for writing, this is also perfect, because the lock will be allow only one person. But if there is no persons wants to write, only the persons wants to read the data, in that scenario, this reading is making a lock. Only one person is allowed to read. But as for the reading is concerned, multiple person can be also allowed to read. So which is not working in this case. So what is the solution? The solution you cannot apply through lock. So we need something else. That something else is called as semaphore. Yes. So what is a semaphore basically? So it is a variable along with two operations called wait, or sometimes called P, and signal called V, to achieve synchronize. Yes, he simply says it is a variable. Since it is a variable, I can simply write it is semaphore S. Yes, it is a variable, he is saying. So S is a variable of a semaphore type. What kind of variable? You think currently at this moment, and after 5 minutes it will change. Assume that I have kept here 1. Okay, so this is the variable where I'm keeping one integer value, simple integer value. I can keep 0, I can keep 1, I can keep 10, like this. Once I keep it, then my first part is ready. It is a variable along with two operations. So what are those operations? He's saying there will be a wait with semaphore S, and there is another function called as a signal with semaphore S. Then what this wait function basically does, he is doing this kind of code, like while S is less than equal to 0, then you will be in the loop, then S equal to S minus 1. And what this signal operation is doing, S equal to S plus 1. Very simple code. So one is wait and one is signal. So this is whole about a semaphore. And he is saying with the help of this wait, signal and semaphore variable, you can able to apply the synchronization. Then we'll go for how this reader writer problem can be solved later. But first, at least we know that with the help of this wait, signal and semaphore variable, we can do it. And at the same point, please remember, these 2 lines code are basically atomic. Atomic means last class we studied, it is not interruptible. Means while it is executing, You cannot, another person cannot enter in the middle and do something. So it is a atomic kind of code. Why it is atomic? I'll come to this point. Why? What is the requirement of it should be atomic? So after a few minutes. So how these two things will be help you in a critical section problem? He's saying, let's take a critical section and we need an entry section. So what is the entry here? The entry is weight of S. And what is the S? You have already declared it is a semaphore. S is equal to 1. You have taken. So what is the exit section? The exit section is signal S. Yes, this S is this one. So let's see whether it is applicable for critical section or not. So what it does, suppose P1 first comes. P1 try to enter into this. What is the S value? S value is 1. So 1 is coming here. So 1 is less than equal to 0. It is false. Since it is false, it comes here. S equal to S minus 1. So S becomes 0. Am I correct? Yes. Once it is becoming 0 because he has crossed this, he has finished it. Now he come to out of this, means he came here. Then P1 is present here. Everybody is clear now how the P1 is entering. Don't think other ways. There is a context switching or not. Those things don't think. Suppose first P1 comes, try to enter. What the P1 does, he is checking whether it is less than equal to 0. If it is less than equal to 0, it will be in loop. If not, immediately go to the next statement, execute S equal to S minus 1. Since our S value is initially 1, 1 is not less than 0, so it is false. False means come out. Then S equal to S minus 1 means 1 minus 1 is 0. Once it comes to 0, then it is finishes wait function. Once a function will be over, obviously next statement executed. Our next statement itself is a critical section, means P1 is currently present in the critical section. When P2 comes at that moment, what happens? Already S becomes 0. So P2 comes. So 0 is less than equal to 0. So he is in the loop. Since he is in the loop, he cannot come here. If he will not come here, there is no question behind this. So what happens? Only one person is now P1 present. P2 cannot enter. Now see, after the P1 comes out, whether the P2 enter, yes, it can be entered, because once P1 finishes its critical section, he is making signal of S. Signal of S says that S equal to S plus 1. Since S value has changed to 0, now it is becoming 1. 1. Whoever is present here, who was present here? P2 was present here. So previously 0, 0 is less than equal to 0. Now it is become 1. So 1 is less than equal to 0, false. Again, P2 enter by making it to be 0. So what basically it does, while wait function executed, the semaphore variable gets reduced. While a signal function executed, the semaphore variable gets increased. Just remember this point, and later you can remember these two things. But why it is atomic? If it is not atomic, what is going to happen? Just look into it. Suppose P1 first enter, its value is 1. Its value is 1. So 1 is less than equal to 0. So it is false. Since it is false, now control comes here. Suppose at this point, the context switching is happening. If the context switching is happening after this point, then another person can enter. So if another person will come here, S is still 1, 1 is less than equal to 0, then what happens here? P2 is also comes here. So P1 was here, P2 was here. Both what will do? Execute S equal to S minus 1. So S was initially 1. 2 person has to be make S equal to S minus 1. So S become minus 1. When it is minus 1, that's not a problem. But when your S value is minus 1, and after that both the processes completed its code. If it is completed its code, both of them will be present here, P1 and P2. So which is not allowed. So that's why it is saying you don't have to make a context switching at this level. Rather, if one person enter, it has to be complete and complete. That's the basic idea. So there is a wait function, there is a signal function. With the help of this, we can achieve somehow mutual exclusion. But why you are learning this? The same thing we are doing by the lock. What's the meaning of learning this one? Let's see. Our purpose was, can more than one person will be allowed to enter into the critical section as per our requirement? The requirement is very simple. Let's assume you have, how you can feel that it is required. You assume that this is my computer. In this computer, only one printer has connected. So if there is a two processes or two persons wants to print that data, P1 and P2, can you say that P1 and P2 directly send it to the printer? No, you have to apply a lock. Yes, no, you have to apply a lock. By applying this lock, what will happen? Even if P1 and P2 made a request for printing, but once the P1 enter, P2 cannot enter into this printer. So one job finished. After that one job will be finished, then P1 has to unlock this, then P2 can enter into this. This is the first scenario. When more than one is required, let's assume that sometimes our computer connected with more than one printer also. It happens because it is a USB printer. I can connect 2-3 printer if I have 2-3 USB ports are available. So in this scenario, if there is a P1 and a P2 try to enter, whether we will allow them to enter or not. Tell me, in this scenario, whether more than one person should be allowed or not?
Allowed.
Yes, and how many max? You have to max allow 2 persons. If there is a 3 process at a time entering, out of 3 process, only 2 you allow it. So that one will be go to this printer for printing work, another job will be go to this printer for the printing work. Not 3 is possible. Means I need a certain kind of a functionality or a technique by which, as per our requirement, some n number of persons should be allowed to enter into the critical section if a requirement comes into picture. So how this is suitable with respect to our semaphore. So what the semaphore says? The semaphore says you take a variable s. So in the same case, I'll assume semaphore s is 2. So if it is 2, now look into very carefully. So 2 comes, 2 is less than 0, first person, suppose P1 first comes. 2 is less than 0, comes out, S becomes 1. When S becomes 1, then P1 is present here. While P1 is present here, again P2 comes, let's take. So P2 checking S, so S is 1, 1 is less than equal to 0, this is also false, then again P2 also comes here. Now what is the value now? Here change this S equal to S minus 1 means S goes to 0. So once it is S goes to 0, who comes? P3 comes. If the P3 comes, can your P3 will be allowed? Not at all, because P3 is finding S is 0, 0 is less than 0 means it is in loop. And what happens? So in this case, 2 persons are allowed. आप बोलोगे sir, yes, ठीक है, but what's the meaning behind this? 2 persons are allowed. Let's 1 person will be come out. Can another person will be allowed or not? It will be allowed because when P2 or P1 anybody finish that critical section and comes out from this, what they're doing? Signal. What the signal basically says? Increase. Increase means previously S value becomes 0 after this 2 person enter. When it is 1 person comes out, let's say P2 has come out, then this will be changed to 1 because he has to be put a signal. So when it is becoming 1, P3 is waiting here. 1 is less than equal to 0, it is false. Since it is false, again P3 enter and make it to 0. Then by this semaphore variable, you can easily say that if my semaphore variable is 5, 5 persons can be allowed. If my semaphore variable is 1, only 1 person will be allowed. So by this way, we can identify more than 1 person may be enter into the critical section at the same time. Yes. Now we can say when my semaphore variable is 1, it looks like a lock. If it is not, then definitely you can say if it is more than 1, then more than 1 processes can be entered into that critical section. So that's why they're saying this semaphore may be of 2 types. Okay, semaphore may be of 2 types. So one is called as the binary semaphore. Yes, one is called as the counting semaphore. Yes, if in this binary semaphore, if I'm taking this val equal to 1, so value becomes 1, only 1 person allowed. Why? When S is 1, 1 person allowed, it becomes 0, unless until it will come out, another person cannot enter. And in this case, if my value is not equal to 1, some n, then n person will be allowed into this critical section. So by this value, I can say this is indirectly a lock, and sometimes it is called as a mutex lock. Yes, why it is called as mutex lock? The mutex comes from the mutual exclusion. The mutual exclusion always says that only 1 person will be allowed into critical section at a time. That is called as a mutual exclusion. As per the mutual exclusion, it is applicable when my value becomes 1. If my value will be considered, which value? Semaphore's value. If the semaphore's value will be considered as n%. So in that case, it is called as a counting semaphore. And if it is only one will be allowed by setting the value equal to 1, then it is called as a binary semaphore. Clear? What is a binary and this? And this binary semaphore called as either mutex or called as normal lock. Okay. Now, one observation you can find out. The basic observation is that when this P1 process enter into this critical section, we studied something that P2, P3, P4 try to enter into this critical section by executing this wait. But wait says that it is a loop. So if it is a loop, what happens? All other processes except the P1, which is currently present in the critical section, are spinning in this lock. So the same spin lock problem comes into picture. Yes or no? Because they will waste CPU time, because they are eating the CPU time by just checking for the lock. But lock is not open now because somebody is inside. So what to do? Make them to sleep. We have studied one concept called as a block with wait locking queue. So in the wait locking queue says that instead of a process has to be spinning at the lock or busy wait at the lock, the process may be entered into the lock waiting queue where he will go and make a sleep. Once the process P1, who is currently present in the critical section, comes out, one of the process from that lock waiting queue will be wake up and execute in this critical section. That's the idea. And how that thing will be implemented, because that is required. Otherwise, what will happen? Your CPU cannot able to execute this critical section properly, even if it is written in a nice way. Because most of the processes, those who want to enter into the critical section, they are eating up the time of the CPU for unnecessarily checking the locks. Yes, then how it is possible? And exactly the same kind of code you can find also in the x86, not any different. Yes, I'll give a hint later for the this semaphore, how it is implemented. Yes, we'll go for what? How can you avoid the spin lock? By implementing a new kind of semaphore. So what the semaphore needs? So semaphore says that I need a value which will be set as a 1 or 2 or something, and I need a queue. Yes or no? I need a queue of this. Then how he is preparing? He can preparing a type def struct, that is int val. This is for storing the value, and another I need a queue. So let's take, you have already studied the queue data structure, and I have create a queue q1. Yes, and this is my semaphore.
Sir,
Yes, please tell me.
sir, that V is 1 and it
No,
is having a queue.
I have just created a structure. I'll set it. Okay, I've just created a simple structure. Previously, I told no, the semaphore is simply an integer kind of variable. Previously, I declared, but now it is not an integer variable. Rather, it is a structure variable. Why? Because it requires two things. It has to be maintain the value. At the same time, it is also maintaining another queue, and this queue is indirectly called as a log waiting queue. Okay, so this is my log waiting.
Sir,
Yes, please ask.
so that value in this V is same. That binary value.
Yes. This is similar. Yes. I'll set it now. So what you have to do now?
That above value. Value is equal to 1 where you have written binary. Yes. Binary value.
No. This may be 1, this may be 5, this may be 6, depending upon the semaphore value.
Yes. So here we are using the counting semaphore.
Look, I can use a binary semaphore, I can use a counting semaphore. If I set it as a 1, you think of it is a binary semaphore. If I set it as a 5, you can think of it as a counting semaphore. For both it will work. Okay? Yes. So how you can do it? Then I need a variable. How to declare a variable? Sir, we know semaphore. Yes. Then how can you set the value? S dot val is equal to 1. Now you get the idea? Yes, this is it. Now how many operations you require? Wait and signal. Now I'll just change a little bit. So wait means what? In some books you can find a P. And what is this? Semaphore S. And what is the other one? That is B. Semaphore S. Yes. Now very interesting. Just look into it. So what is the first job of this? So he is saying this P code will be like this. So whatever the value will be when wait function. So this is indirectly I am writing so that you don't have to confuse. So this is our wait function. This is our signal function. Okay. So what it does basically, he is saying S dot value equal to S dot val minus 1. Okay, first whatever the value he is making minus 1. Then he is saying if S dot val is less than 0, then you make them to sleep. So insert the process P into S dot Q and slip P. Got it? What it does? He is saying that this P process, P stands for the process, this process. This P process which is executing this, make them to enter into this queue, this queue whatever you have created here, this you have created this Q1. Okay, this P has to be entered and make the process to be sleep. If it is like this, I'll discuss. And what the V operation says, same style little bit. S dot val is equal to S dot val plus 1. Then we'll see whether it is working or not. Then if our S dot val is less than equal to 0, then I can say here, then we have to make a delete. Then P is equal to delete from this S dot Q1 and wake up Q. Wake up. Got it? That's all.
Excuse me, sir.
Yes,
Sir, semaphore variable means a number of process that can enter together in the CS, I mean critical section, right?
very nice. Very
So
nice.
sir, here in wait you write that S dot val less than 0 means no process can enter, so it is made sleep. But here, yes.
First, this code is saying it is less than equal to 0. Very perfect. Yes. And we have checked it. But here I am writing less than.
Yes.
Just you have to wait. Just wait for 2 minutes.
Okay, okay, sir.
And then you can ask me. This is now we are checking whether this code is satisfying or not as per our requirement. What is the requirement? First I'll check for the binary semaphore. It has to work. Then I'll go for some counting semaphore with 2 or 3. Let's say 2% has to be entered, not more than 2% will be entered. If more than 2% will become, rather than they are spinning in the lock, rather they will be enter into this queue. And whenever one of the processes, those who are present in the critical section comes out, one of the processes from the waiting queue has to become and execute. That's our idea. Okay, whether it is satisfying or not. So what you have discussed? We have discussed I have S which has a val and which has a Q. Yes, so this is my S. So currently val is 1. So what is the code? The code is P of S, then critical section, then B of S. Okay, let's assume that S is 1 initially, means we are doing for the binary semaphore. If you are doing for the binary semaphore, suppose first P1 comes. See the code, P1 comes. What you do? Come here. S dot value equal to S dot value minus 1 goes to 0, correct? If can it is less than equal to 0? Sorry, less than 0. Can your 0 is less than 0? No. Can it will enter into this? No. Where it comes? P1 comes here. Correct or not?
Yes, yes.
First point is okay. Yes. Now what is your requirement? The requirement is if P2 comes now, what is going to happen? P1 is still here. And what is happening? P2 comes here. P2 wants to go here. S value equal to minus 1. So 0 minus 1 comes to minus 1. Correct? Then -1 less than 0. Yes, sir, -1 less than 0. Then what happens? This process P2 is now entering into this place. Accepted?
Yes, sir.
Yes. Now one more, not over. This is or this. Then what again happens? Suppose one more process comes, P3. Again, still P1 is present. So P3 comes. P3 is checking S value equal to -1. So -1, -1. So comes -2. And P3 is present here. Okay. Then what happens now? Let's take P1 finish its work. If the P1 finishes its work, then P1 completed. P1 comes out. When it is coming out, what is doing? Just look into it very carefully. He has to be executed V code. In the V code, what you have written? S value equal to S value plus 1. So kitna hua hai? -1. Correct or not?
Yes.
Yes. Then can your -1 less than equal to 0? Yes.
Yes.
Since it is S, what does it mean? Some processes are present in the queue. Yes or no? Because our value is currently -1. Since it is becoming -1, -1 less than equal to 0 means one process, some processes are present. Then what he does? He delete one, and make this deleted one to be wake up. Then who is now wake up? P2 wake up. Then what the P2 has to be do? P2 has already completed up to this much, correct or not? P2 has already completed up to this much. Then can your P2, P2 has already completed up to this much. Am I correct? This much. Then what will do? He has to wake up. When will wake up, what to do? He entered here. Once it is entered here, now you can say, sir, still P3 is present. Can your P3 is working? Let's see whether it is working or not. When P2 comes out, when this P2 comes out, again comes here, this -1 goes to 0. Yes. Can your 0 is less than equal to 0? Yes, sir. Means one more process is present. If it is one more process is present, then what happens here? This has to be come out. So now he has already come out. Now P3 enter. When P3 comes out, now look into it. What it does? S value equal to +1. So this goes to 1. Can your 1 is less than equal to 0? No. Means nobody present. So it's working perfectly. Got it? The one it's okay?
Yes, sir. Yes, sir.
Yes. So this thing. So similarly, if you can go for setting that S equal to 2, same thing you can find it. Suppose initially S becomes 2. Sochiye 2. Then first process jayega. Suppose sochiye first process will go. So P1 will go. Okay. Then 2 value will be goes to what? 1. Sorry, 1. 1 is less than 0. नहीं जाएगा. So कौन है? P1 है. फिर से P2 आया. P2. So check क्या? 1 minus 1 is becoming 0. Can your 0 is less than equal to 0? No, sir. वो भी नहीं गया. When P3 comes, then 0 minus 1 becomes -1. So it is -1. -1 is less than 0. Means अंदर चला. ठीक है कि नहीं? Working? So similarly, if you can apply it here, definitely. So very simple principle is that when a process enter, you have to make it to minus just for the sake of understanding. हाँ, क्योंकि जब भी आपका क्वेश्चन में आएगा, आप तो पूरा नहीं देखोगे ना. सर लिखा गया था while s is less than equal to 0 ऐसे कुछ लिखा गया था. बेसिक पिक्चर क्या है यहाँ पर मिला हमको? When you are making a P operation or weight operation, this value reducing. When it is V operation, this value increasing. By this way, the adjustment. Now you can argue, sir, how it is spill log is avoided? One simple observation. The observation here, if you can go for this, sir, here it is a loop. मतलब एक बार कोई प्रोसेस आ गया ना, यहाँ पर घूम रहा है बस. while loop है, ये घूम रहा है. But it is not a loop. It is simply a if condition. It is simply a if condition. मतलब वो एक ही बार इसको condition check करेगा, either true or false. True होगा तो अंदर जाएगा, it will be going to sleep. False होगा तो बाहर आके it will go inside the process. So always you observe these things, two things, when you are in loop, when you are not in loop, as per the critical section and spin log is concerned. अगर कुछ looping वगैरह है, while loop वगैरह, मतलब उसको avoid करना पड़ेगा. How? You make a queue and make a if statement for that. Condition तो चाहिए मुझे, because without a condition, everybody, suppose if there is no condition here or no condition here, This is simply a function. Anybody will come and enter, execute it and come inside the critical section. Condition jarur chahiye. But whether you are applying this condition with while or applying this condition with if. While karne se acha hai, where you don't have to maintain extra queue kind of things, where everything has to be managed. But if you don't like this, if you want to avoid this spill lock, you have to maintain a queue and at the same time prepare the insert function and sleep. Okay, understood? So this is basically as asked, please.
सर ऐसा स्लीप का एक कमांड है तो वेक का क्या कमांड है वेकअप का
Wake up ka? Oh, sleep, wake up here. That depends upon your program to program. I think in Java programming language, it is a wake up and wake up all. Wake up means only one process will be wake up from the sleeping state. Wake up all means all will wake up. But now you can say, sir, if all will wake up, how it will happen then? So what will do? Out of all the wake up, again the scheduler take a decision among all who is suitable. But in this case, what you are doing? You are following exactly a normal queue. जो आगे है वो पहले wake up हो रहा है and going to this critical section. But it may happens during the working of this P1, P2, P3, P4, like 10 processes are enter into this sleeping state. Then who will execute it when P1 comes out? One can say, sir, as for the queue, the way they are coming, FCFS follow kar dijiye. Or koi bolega, no, sir, don't follow FCFS. We have a priority system. So whoever is present here, among these processes, whichever is the highest priority, that process will wake up. But for that, you make a wake up all, then the scheduler take a decision that among all these processes, who is the highest priority, bring them out, others again make them to sleep.
Sir, in C, what is the function wake?
That is a signal is there. Only signal, and I think signal all is also P thread में. एक बार देखिए.
Okay, sir.
Signal.
क्या वो sequence क्या होगा? मतलब waking up का?
We can go sequence. In this sequence only FCFS.
मतलब जो क्यू में आया पहले वही.
Yes, वो पहले आएगा. But somebody may say that you implement a priority based wake up. Priority based wake up means those who are currently present, you don't look who has come first. Rather, among these processes, whoever has the highest priority, he will wake up and go for this. That also can implement. Okay? It's okay? Understood?
Yes, sir.
Okay. So we'll now go for very interesting problem where you can find out some kind of difficulties. Yes. So that is called as some classical problem. One is called as the producer consumer problem. Yes. So producer consumer. Or sometimes in some books you can find it is called a bounded buffer problem. Yes, there are three problems given in our book as per the course. One is producer consumer, one is the reader writer, one is dining philosopher problem. So during these two classes we are going to study these things. Please look into it carefully. First we'll find out what is the problem, what should be our solution. In that solution, what is the problem and how this solution can be properly solved. Problem can be properly solved by using Semaphore. That's how. So the problem is very simple. Think that this is a rack. This is a cake shop, and this is a rack. So there are many producers producing the cake. X company, Y company, Z company are producing the cake, and there are also many consumers who are ready to eat those cakes by purchasing this. So there are many producers, you can say, so P like this. There may be also many consumers like C. So all are using the single buffer. That's why it is called as a bounded buffer. So one buffer, the buffer is a collection of memories. And in this memory, the producer has to keep some data. One cake he has kept. This fellow may keep a cake. This fellow may keep another fellow may keep this cake, and the consumer has to take this cake. Eat the cake. How you can make it synchronized? Why the synchronization required? There are two problems comes into picture. When the producers will become, they will fight each other. मैं पहले जाके मेरा केक रखूंगा. बोल रहा है ना, कंपनी पीपल आते हैं जब कोई शॉप को, सपोज मेडिसिन शॉप को, वो बोलता है मैं पहले डॉक्टर के साथ मिल लूंगा, so that my medicines will be prescribed by that doctor. So that may be one reason, because these producers will be fight each other that whose cake will be first to keep in this rack. Okay. Similarly, the consumer can also fight among each other. Why? Because the consumer will be fight that, hey, I want to take this cake. He will say that I want to take this cake. The consumers fight. And there is also fighting between producer and consumer. जब producer आ रहा है रखने के लिए, consumer है मुझे छोड़ दीजिए मैं केक खाऊंगा. So producer is telling, no, I have to first keep it. So there are fighting between three people, among the producers, among the consumers, and among the producer and consumer. So three-way fighting is there. So how you can avoid it? Now you can think a little bit that, sir, for this, definitely since it is a rack, there must be kind of locking kind of things required. Means one person will be at a time accept this particular rack. Once you'll keep it or once you'll take it, then another person will come. Then how you can apply this lock in a nice way so that both producer and the consumer work out? Because here there is no only producer. If there is only producer, you don't have any issue. Why? You can simply say that I'll put a critical section is my entry the cake is the critical section, and my entry section is lock and exit section is unlock. Very simple work. But since there is a producer and consumer, the producer is executing their code separately, consumer is executing their code separately, definitely I need some kind of extra code is needed. So let's write a dummy code for this. What is the problem? So let's say this is my producer code.
Sir,
Ask.
sir, here we can use that previous that weight and
Yes. Now you think that whatever the P and V operation now you are going to use, all are using this weight, lock waiting queue. So that there is no question of a spin lock there. Assume like this. We are not using a ordinary P. Now you think that we are not using this P. Rather, you are using this P and this kind of P. Okay. So now what is the producer's work? Assume that my cake rack has only 5 elements. 0, 1, 2, 3, 4, 5, 6. 6 element. Okay. This is a 6 element rack. Now you tell me how first what a producer comes, he will say that I produce an item. Produce an item. So what is this? This is PI. That is my P item. P item is my produce. Once it will produce, then what you have to do? He wants to insert into the rack. Tell me when he cannot keep inside the rack. Suppose the producer produce करके एक cake लाया है. When he is not going to keep inside the rack, what is the scenario? If the rack is full, rack is full. Now for the full case, what you did, since my 0, 1, 2, 2, 3, 4, 5, since my total is 6, so I can take a count here. The count is initially 0. So if the count is initially 0, if my count becomes 6, then I can say that yes, nahi kar paunga. So kya karoge? If my count is equal to n is here 6, then I am going to sleep. Is my code is correct or not? मैं produce किया, then check किया. If the count becomes 6 or n, means all the racks become filled up. Means I don't have a place to keep the rack. So I have to wait here on. I cannot do anything, make me to sleep. If not, if this rack is not filled up, what I'll do simply, I'll say, sir, I'll insert कर दूंगा. कहां पर? Sir, rack में करूंगा. क्या? P item. Correct? After doing these things, immediately you say that, sir, मैं ये भी कर लूंगा. Count plus. सही लिखा क्या नहीं लिखा? यहाँ तक सबको समझ में आ जाना चाहिए. I produce a cake. I check that whether my rack is full or not. If it is full, I'm going to sleep. If not, I simply add it to the rack and make the count to be plus plus. Very simple. Yes. Then if it is done, once I'll keep it, is it my any duty यहाँ पर मेरा बनता है कुछ करने के लिए? After I keep this cake, something has to be do.
Yes. To let the system know that producer has done its job, and consumer can take.
कंज्यूमर को चिल्ला के बुलाएंगे, मैं रख दिया हूँ केक, आप आ जाओ खाने के लिए. कब बोलेगा? पहला केक और मिडिल में भी बोलेगा.
पहले रखने के बाद भी बोल सकता है ना, क्योंकि एक तो है रैक पे.
Only first time you have to shout. Second, third, fourth time, is it necessary to shout?
No, because consumer has already came.
Yes, very nice. Then you can immediately say, if my count is equal to 1, then wake up some consumer. आप बोलोगे सर wake up क्यों किए? Because if before this, if no cake was present and if any consumer has come, what the process has to do? Make them to sleep or not? है कि नहीं? क्यों वो करेगा? Why he has done? Because all producer and consumer are executing in a single what? Machine. Means how many processor you have? One processor. Think in this way. If you have one processor, then if the consumer has not sleep, then many consumer will be knock the door when this producer is going to keep their cake. So producer cannot keep, consumer cannot eat. That's why some consumer may be also in the sleep state. That's why when first cake has kept, that time wake up is necessary. After that, you can say that immediately consumers are coming, that cutting. So no issue. Similarly, think in the consumer side. What the consumer has to do? Is there any production required at the consumer side? No, but eating चाहिए. कब eating नहीं कर पाएगा? Very nice. Very nice. Sleep. Good. If not, if count is not 0, means high, then what to do? Delete.
And
come back. Yes, and get some period. And this count
minus.
Sorry, minus बदल ये लिख लो. अच्छा, then बोलिए ये कब चलाएगा बोलिए तो
फिर से जब काउंट 0 हो जाएगा.
नहीं, कंज्यूमर कब चलेगा? प्रोड्यूसर आप आ जाओ रखने के लिए.
हाँ, तो केक खत्म हो गया ना, तब तो काउंट
नहीं जब भर जाएगा
तो नहीं हो सकता कभी.
छह रैक से किस पोजीशन पे कंज्यूमर चिल्लाएगा कि प्रोड्यूसर आप आ जाओ रखने?
1 पे सर.
नहीं, 1 पे तो और जगह है, बहुत सारे कंज्यूमर
ज्यादा भूख लग गया तो
5 पे. Am I correct? When a count becomes 5, then
जब भर गया तो okay, yes.
Because previously count is 6, that's why they cannot enter. But the moment 1 is empty, that time it has to be good. Then you can immediately say, if my count is equal to n minus 1, that time somehow we are going to wake up. Producer. सही क्या? क्योंकि देखिए n जब 6 था, हमारा n है total 6. When it is 6 means it is full. Nothing has to be done. They are sleeping. When it is 5 means पूरा फुल था, रैक पूरा फुल था. पहला एक कंज्यूमर आके एक खा लिया, मतलब उस टाइम पे बोलेगा कि ए आप लोग जो सो रहे थे, कौन सो रहा था? जो प्रोड्यूसर. When the producer was sleeping, that time you will say that please come and keep your cakes so that we are ready to eat. Yes, but when it is 4 or 3 or 2 or 1, it means that there are many producers are already there. They knows that it is empty. But when it is full and first cake was removed from that full rack, that time it has to be intimated. Like here, when it is completely empty and the first cake was kept inside the rack, that time he is calling. Okay, that is the basic idea. We have written, but it is a completely wrong code. What is the wrong code? The very basic wrong code is, this is a global variable. And this global variable are used by two threads simultaneously. And what you are expecting? You are expecting that my producer and a consumer sequentially executing this count plus plus and count minus minus, which is not. As I told, this count plus plus and count plus plus internally may be a 3 lines code. And we studied when a P plus plus will be done 1 lakh time by two threads, the total result has to become as a 2 lakhs. But instead of 2 lakhs, sometimes it is coming 1,14,000, 1,12,000. We have seen this problem or not? In the same scenario will come when a context switching is happening here, and this also context switching happening here. He wants to make a minus minus, he wants to make a plus plus. So during this execution of a count plus plus and a count minus minus, when the actual context switching takes place, definitely your count is not giving a proper result. If count itself is not proper, can your rack will be filled and the rack will be empty works properly? Cannot. So this is the basic problem which you have already studied when you are creating two threads and wants to increment the p value 1 lakh times simultaneously. The same one, think that the whole thing become 1 lakh size array, and this wants to increment, this one to decrement. So if both the things will be done simultaneously, then definitely inconsistency comes in. And what I need to avoid this inconsistency, this area to be synchronized. If this area to be synchronized, I have to put a lock. What kind of lock? Either you can use a hardware lock, or you can use a software lock, or you can use a Semaphore. But here the question is a little different. Here is saying, sir, it cannot be a direct lock. Why it cannot be a direct lock? It may happen, sir, inside the shop, if there is a 1000 size rack is there, the shopkeeper or the shopkeeper manager may tell 2-3 producers to tell you, please go inside, no problem, you wait inside the hotel, and one after another you keep inside the rack. Then what happens? More than one persons are allowed to enter into the hotel at a time, which is not applicable through lock. Then what I need certain kind of Semaphore which will be flexible for me to allow multiple persons. Even if it's allowing multiple persons to enter into the hotel, but to touch the rack, only one person. Are you getting my point? What I am to say? If this is my big hotel and this is my rack, I'll say I can allow many persons to come here. Suppose the capacity of this area is 10%. So I can say, sir, this manager will say 10% you can allow here, not an issue. But to touch this rack, only one by one. Even if the 10 persons are standing here and here and here like this, but touching this person by only one. And who are these standing people? These standing people, maybe few of them are P's, few of them are C's. Means there are few consumers are entered, few producers are entered, but when they are taking or keeping the cakes inside the rack, only one, either a producer or a consumer. So what kind of Semaphore it is required? Now you can see, so you have two level restriction you have put it. One restriction you told here, sir, there is a number of people can enter here. So that is one restriction. This can be solved by a counting Semaphore or binary Semaphore. Tell me please. The number of people can be entered. Counting Semaphore. But this area which is accessed by only one, that by a binary Semaphore. Okay, so how this counting Semaphore and binary Semaphore will solve this problem? Let's see. Okay, how interesting that man. Yes, so they're saying you take a Semaphore is a data type. How many variables? So he's saying you take 3 variables. Sorry, एक ले लीजिए mutex, one वो binary Semaphore. So ये mutex किसके लिए काम करेगा? पूरा rack को touch करने के लिए. This is for this. Then what is the other one? Other one is one for the producer, one for the consumer. Producer क्या देखेगा? जितना खाली है मैं जाऊंगा. Consumer क्या देखेगा? जितना fill है मैं जाऊंगा. Is it correct or not? The producer will check that if it is n empty, then n producer may be enter. Consumer देखेगा if it is m fill, then m consumer can enter. That's the idea or not? Then what is? He's taking two more variables. One is saying empty for the producer. Basically for the producer. And what is the empty? You have to tell me. And one is full, that is for the consumer.
Sir, what is this empty and full?
So empty क्या बोलते हैं? Suppose सोचिए अभी rack, now the rack has 3 places empty. Then the shop manager will send how many producer to enter so that it will better.
Oh,
3.
Three.
Yes. If there is a 5 places are filled up, then how many consumers should be entered so that nicely they can do it? 5 consumers. So that's why they have taken 2 separate variables. Empty. If my empty is 10, means 10 producer can enter. If my full is 3, then 3 consumer can enter. So empty and full is indicating that how many places are vacant, how many places are filled. Yes, and if you can look into it at a time, at any time, your full and empty, if you can add it, that should be equal to what?
N.
Very nice. That is it. So if n is that, can anybody tell me now what should be the initially empty and the initially full? If you have understood, somebody has already told n.
Empty is that n, and full is 0.
Full is 0.
Empty is n and full is 0. Very nicely understood. Now you tell me, if empty is a semaphore variable, he will be allow the person or not allow the person?
Allow.
Allow the producer.
Yes. If the full is 0, can it will be allow the consumer or not allow the consumer?
Not allowed.
Not allow.
Yes. हम लोग पढ़े 0 हो जाएगा तो किसी को अलाउ नहीं करता है क्रिटिकल सेक्शन में semaphore. अगर 1 या 2 या 3 है, depending upon if it is 3 processes can be entered into the critical section. Now you can say at the very beginning stage, your shop is completely empty. That's why the total rack empty is n. And since it is empty, full becomes 0. Full becomes 0. So that's why it's 0. So how they have written then producer function and consumer function. So can you say same style? He is producing, produce. Yes, item. कौन? कोई एक प्रोड्यूसर प्रोड्यूस कर दिया. क्या क्या? एक पी आइटम करके. And you want to enter? कैसे करते हैं? How will enter? Can you directly enter or will put a restriction? Now what is the restriction? तो सोचिए यहाँ पर रैक है, यहाँ ये लोग खड़े हैं. प्रोड्यूसर जाना चाहता है. This producer wants to go. He has to verify something or directly enter.
Verify.
What? Which variable he has to verify? All are 3. Empty.
Empty.
So you can say PMT.
Empty is not 0.
PMT knows how to manage. Yes or no? We have written no P and V operation. PMT knows how to manage. Once you will enter, then you will look for this. Yes or no?
Yes, the mutex.
Yes. If you look for this, can you directly enter or he has to do something to enter?
So first he has to check that mutex is 1 or not.
Very nice. Then you can say that P mutex. Accepted or not? PMT बोल रहा है कि आपको दुकान के अंदर घुसिए. P mutex बोल रहा है कि only one person will be allowed to touch that rack. Because mutex is 1, then only max 1 person will be allowed. Empty is n, then n person will be allowed. Now you can say at this stage, there may be n number of producers are standing. Am I correct or not? At this stage. But at this stage, only one producer will be present. If it is present here, now tell me what he has to do. Suppose ये यहाँ क्रॉस किया, यहाँ भी क्रॉस किया, मतलब यहाँ रैक पे है. So what he has to do? He has to be
insert count plus
into rack.
Empty minus full plus.
Yes. After he keep this rack, he has to be come out from this rack or not?
Yes, sir.
Yes. Then during this P mutex, the mutex variable change from 1 to 0 or not?
Yes.
Then what he has to do so that again he has to make a 1?
mutex equal to 1 or set
mutex.
mutex. Okay.
अभी बड़ा बहुत इंटरेस्टिंग चीज पूछ रहा हूं, अगर आप पहले से जानते नहीं हैं आप लोग के लिए, बोलिए. Once this p mutex, suppose 10 था, n था आपका 10, yes, n था 10. When suppose first person has entered p1, then empty क्या हो जाएगा बोलिए? 9. अगर ये 10 था वो 9 हो जाएगा. 9 होने पर after that, can you wants to tell to somebody that you take it the cake?
Yes sir.
किसको बोलना चाहिए?
Consumer.
Consumer को.
But consumer will be entering into the shop with which variable?
Full.
Full. अभी full. What is the current value of full?
0 plus
What
minus.
Wake up.
What you have to do so that the consumer can enter? Full has to be
plus.
Full has to be increased. Why?
Yes.
Which kind of operation will make the full to be increased?
P of full.
B of full. Very nice. खत्म हो गया, कंप्लीट. क्या किया देखिए, एंट्री किया एम्प्टी के थ्रू, सो दैट यहां पर माइनस हुआ एम्प्टी. अंदर गया, he has produced the things, means kept the things in the rack. बाहर आ गया. जब बाहर आया, he is telling to this consumer that I have increased the full. Now we can enter. Yes, in the same manner. In the same manner, what the consumer has to do? What way the consumer has to enter? The consumer will be entered by full. Correct or not? If full is more than 0, then that many consumer will be entered. After entering into this consumer shop, what he has to do? He has to check it here. How will check it here? Same p mutex or a different? समझ पा रहे हो आप? समझ रहे? So क्या करोगे? Same p mutex. Yes. Then यहाँ पर it किया, मतलब delete from rack. That is p item. Yes. After he take the cake from this rack, he has to be come out from the rack. Means b mutex. Next class फिर से detail, हाँ? b mutex. Then जब आ जाएगा, इसको कुछ बोलना चाहिए. ये क्या किया बोलिए, देखिए. एक खाली कर दिया मतलब empty एक increase होना चाहिए कि नहीं?
v empty.
Very nice. खत्म, फिनिश.
तो मतलब वही है ना, वो VMT वो शाउट करेगा जब मतलब
Yes.
वो
एक खाली होगा
जब पहले से फुल था.
ये हर टाइम शाउट करेगा. सोचिए, देखिए, जब भी एक खाली कर देगा, वो बोलेगा कि मैं एक खाली कर दिया हूं, मतलब एम्प्टी एक बढ़ जाएगा कि नहीं. ये देखिए, ये जब जा रहा है एम्प्टी को कम कर रहा है, जब बाहर आ रहा है रख के, देन बोल रहा है कि फुल मैं एक बढ़ा दिया हूं. ये क्या कर रहा है कंज्यूमर? व्हेन इज एंटरिंग, फुल को एक घटा रहा है. सपोज 5 फुल था, अभी 4 हो गया. And since it is full is reducing, empty has to be increasing or not? Means this and this will be interchanged, and this will be interchanged. Yes, and this mutex should be set. But somebody may write 1 minute. Somebody may write, can I write one more variable? It is a mutex 2 equal to 1, and I will use here mutex and mutex 2. It will work or not?
It will work, sir. It will work because after each operation the mutex value is same.
No, you just tell me whether it will work or not, because this part will work very nicely. Empty बोल रहा है कि मैं खाली कर रहा हूं, फिर full को बोल रहा हूं कि आप जाओ. Full बोल रहा है कि मैं खाली कर, sorry, empty बोल रहा है I am keeping it and telling to the full that you can enter. Full बोल रहा है कि I am eating, telling to the empty that you can enter. This is very nice. But I have just changed this. I kept here a binary semaphore. Here also a binary semaphore. It will work or not?
It will work, sir.
Work or not?
It will work.
It will work. Anybody else? सोच के बोलिएगा. ऐसे नहीं कि मैं पूछ रहा हूँ मतलब उनका आंसर wrong है.
Sir, but the two are modifying 2 different variables, ना?
Very nice. काम नहीं करेगा. क्यों काम नहीं करेगा बोलिए? ये बोलना है कि I am entering into this area with a different lock. He is saying that I am in a different lock. Means when he has entered, its mutex value changed to 0 or not?
Yes, sir.
Yes or no? But at that time, do you think that he cannot enter? He can enter. Because his mutex two variable is still 1. समझ पा रहे हो? तो क्या चाहिए? मुझे same mutex variable has to be used here and here. Means same lock has to be used here. So that's why only one is required. Got the point? समझ पाए? ये बहुत क्रूशियल है. जानबूझ के वहां पर थोड़ा सा 1 2 कर देंगे, बोलेंगे कि इस कोड में फाइंड आउट करो. आप बोलोगे ये सब तो सही लग रहा है, but here it is a different. Because here you are finding that this mutex is gradually reducing to 0. But if I take a different mutex, he can also enter. Then what's the problem? The problem is this rack will be touched by one producer, one consumer at a time, which is not applicable as per our code. Got it? Little understood?
Yes, sir.
Yes. So next class फिर कल और interesting है reader writer. वो जबरदस्त है. इससे
सर सर वो राउंड रॉबिन में सर वो प्रायोरिटी होता है.
राउंड रॉबिन में प्रायोरिटी होता है. राउंड रॉबिन विथ प्रायोरिटी.
सर तो उसमें जो बनाएंगे, इंप्लीमेंट करेंगे ना, तो फिर उसमें हम लोग क्यू डेटा स्ट्रक्चर यूज करेंगे.
आप क्यू डेटा स्ट्रक्चर यूज करोगे जब एक प्रोसेस ना खत्म हो गया, सपोज उसका 2 सेकंड खत्म हो गया, ठीक है ना, सपोज क्वांटम टाइम है 2. Once the two units of a current running process gets over, whoever was present in the queue,
first one
among this, whichever is the highest priority, that will get a chance.
Oh, ठीक
है ना.
तो फिर वहां पे वो प्रायोरिटी क्यू डाल देंगे.
प्रायोरिटी को किसमें इंप्लीमेंट होता है? जल्दी बोलिए, जल्दी. हाउ टू इंप्लीमेंट द प्रायोरिटी?
Sorry.
Heap usually heap के through implement. ठीक है.
Yes.
Okay, now I'm ending today, huh?
Sir.
हाँ बोलिए सुन.
हेलो सर.
हाँ हूँ.
सर असाइनमेंट का क्वेश्चन नंबर 3 में डाउट है सर. उसमें
क्या डाउट है बोलिए.
सर मुझे सर इसमें सर time.h हेडर फाइल को इंक्लूड करना है सर, बट वो डिफाइन नहीं है, और मैं सर बाहर से डाउनलोड करके उसमें डायरेक्टरी में डाला x36 का, तो सर फिर भी एरर आ रहा है सर. कैसे
time.h क्यों इंक्लूड करोगे? Why you are going to include?
क्योंकि सर time.h से सर अपन को अगर कैलेंडर का अगर सिंपल अगर cal कमांड है तो हमें बेसिकली प्रेजेंट डेट का कैलेंडर प्रिंट करना होगा.
हाँ वो है. समझ गया. वो आप डायरेक्टली नहीं कर पाओगे. मैं समझ गया.
सर वो कैसे होगा सर?
तो आप क्या करोगे? मैं बोल रहा हूँ. आप जब भी इनिशियली शुरू करोगे, you always pass what is actually the Unix system has calculated the whole thing based on the 1917's calendar.
Yes sir.
Okay, so you inside your whole data now you remember that what is the 1st January of 1900.
Yes sir. ये सब हो गया सर, बट सर ये नहीं हो रहा सर, एरर थ्रो करता है लास्ट में.
नहीं, आप अगर डायरेक्टली वैल्यू दोगे कि 1st जनवरी है मंडे, 1st January of 1970 is Monday. If the user was asking for this, then no need for this time.h. No, that I am saying.
ओके सर, मतलब सर मैंने बनाया सर, डायरेक्ट बनाया था, मतलब आप बोले सर खुद से डाल दो उसको, मतलब अभी डेट.
हाँ, खुद से डाल दीजिए. अभी वो एंट्री मत कीजिए अभी.
अच्छा सर, फिर भी उसका कोई तरीका नहीं सर, उसमें पूरा कोड लिख चुका हूं सर.
मैं निकाल के बोलूंगा, तरीका होगा नहीं कैसे? मैं अभी ट्राई नहीं किया ना, आपको क्यों वो ब्लॉक करूंगा कि ये कर दो वो कर दो.
अच्छा ठीक है सर.
मैं आज अगर टाइम मिलेगा देख के बताऊंगा.
और सर एक और डाउट सर मैंने बनाया सर वो ग्रेगोरियन बेस्ड है सर, जूलियन भी करना है. कैलेंडर है सर.
वो क्या होता है, थोड़ा बोल दीजिए.
कैलेंडर दो टाइप का होता है ना सर, एक होता है ग्रेगोरियन बेस्ड होता है और एक होता है जूलियन बेस्ड. जूलियन में सर नंबर स्टार्ट होता है 1 से 365 या फिर 366 डिपेंडिंग अपॉन whether it is leap year or not.
We can start with 1 and other calendar में कहां से शुरू होता है?
सो उसमें भी सर 1 से स्टार्ट होता है बट एंड होता है 365 या फिर 366 में इन केस ऑफ जूलियन.
Oh, when it will be 366, you can take with the 356 or 365 days, and you have to find a leap year with sometimes only that
Okay,
condition
sir.
only.
Okay, sir, I will try.
Okay.
Okay, sir.
सर क्वेश्चन 3 में से यही प्रॉब्लम मेरा भी था कि लाइक अगर हम सिंपली कैल कमांड देते हैं तो हमें करंट मंथ और ईयर का जो कैलेंडर करंट ईयर का जो कैलेंडर है वो प्रिंट होना चाहिए। लेकिन सर करंट मंथ एंड ईयर पता करने के लिए XP6 में कोई फंक्शन नहीं मिल रहा था सर सर्च करने पे। तो सर अभी 3 कमांड्स का सर हमने क्वेश्चन 3 बनाया है कि लाइक अगर सिंपल कैल प्रिंट करता है तो वो एक डिफॉल्ट ईयर का कैलेंडर प्रिंट कर देगा। अभी के लिए हमने उसे 2022 रखा है। फिर अगर कैल एंड ईयर पास करता है तो वो उस ईयर का कैलेंडर प्रिंट कर देगा। और अगर कैलेंडर मंथ और ईयर देता है तो वो किसी पर्टिकुलर मंथ ऑफ ईयर का कैलेंडर प्रिंट कर देगा। सर ये सर इतना काम करेगा सर? इतना काम करेगा। लेकिन वो जो क्वेश्चन पूछा मैं आज देख के बताऊंगा, टाइमर जो है हमारा उबुंटू का timer.h जो है वो क्या एक्सेस कर पाऊंगा कि नहीं आज देख के बताऊंगा।
ये सर देखिएगा सर, बहुत लंबा लिखा हुआ, सब काम नहीं कर रहा।
मैं ट्राई करके आज बताऊंगा।
ओके सर, थैंक यू सर।
थैंक यू वेरी मच।
Thank you, sir.